Hi everybody, skip to about 30 seconds to get right into it, otherwise I'll start right now. Hey everybody, this is sort of a side project. I've got about 20 or so going on at once, so I thought I might post about it. It'll help me remember things if I forget later, just review the video. So this is about powering a single board PC, like an Orange Pi, Apple Pi, Banana Pi, whatever Pi. I'll be using an Orange Pi 1 in this video, so this is powering it by a battery, a wall, wirelessly, or in another video I'm going to do solar. So in the setup, this battery kind of acts as a UPS, so it's always going to be on whether charging or not, and yeah, just like a continuous flow. So right into it. Now some of these components aren't always referred to what I'm calling them in the video. Like some are called by whatever number. But this is just the chip, the small chip that's on the PCB. So I'll describe them and show you what they look like online later on. Cool, now I've got all my bits and pieces. I won't show off my awesome starting skills in this video, but trust me, I'm really good at it. I would love to do close-ups on all of these, but my camera doesn't autofocus when recording video. So first we have this TP4056 with a Type-C connector. Now this is used for charging a battery. You can also power the device from a battery or from an external power source through the Type-C connector. Now this next one, it's got a couple of names, but let's just call it the LM2577 with display. This is a DC to DC booster. It'll take the input voltage from around 3.5 volts and boost it up to something really high, but for this project I just need 5 volts. I recommend getting the display model of this so you can work without a multimeter. It has a button on it that you can press. It'll show you, it'll cycle between input voltage and output voltage, so you can kind of get an idea of what state your battery is in at the time. Now from the LM2577 I'm connecting the Orange Pi via the GPIO pins, general purpose input output pins. You can see how I do this later on in the video. Now we get a green light on the Pi, meaning we've got an OS booted. That other board plugged into the Pi is a PWM breakout board. Now I'm going to connect the TP4056 to a power source for my PC. It is now charging the battery and supplying power to the Pi. This board gets very hot, but don't worry too much, it's normal. Now I'm going to supply it with wireless power like magic. I'm using some random supplier with a phone wireless charging pad. Using just one isn't really effective, so you want to add a few more later on. Now off with the wireless charger and back to the PC supplied power. Here, pay attention to the Pi. Input voltage and output voltage. The only thing that changes is the supply voltage. The Pi keeps on going. Now let's look through the local market and international market so you can see exactly what I brought, find the same thing available to you, and just see the price difference just for fun. Now this is the same power bank that I gutted the batteries from. They're a safe bet being from a retail device and Samsung batteries. Once in a while when buying batteries, the listed voltage on the battery may not be the same voltage that's actually inside the battery. So when you're combining batteries to make a single cell, you want the voltage difference to be like within 0.0 maybe 5 volts difference. You don't want too much variance or trouble can happen. You can read about it online. I haven't made a video about it yet, but I might do it in the future. The servo, to be honest, I don't know enough about this to guide you through what makes a good servo or not. From what I know, analog or digital servos are your choices, but digital servo, although much better, requires a whole lot more current to run it. So this poor battery pack I've made won't really do the job. Now to a DC to DC booster, LM2577. Now check against this first product with the one you might want to purchase. See if everything is the same, namely the display. Now, like I mentioned before, simply searching for the chip name yields many results. What you want is what I got in the first listing, so scroll down a bit and a bit more. Now this is the PCA9685, the PWM breakout board. Because the Pi only has one PWM pin on it, you need this board to make more. Now one thing I didn't show is that this needs its own power supply, another 5 volt in, where the green thingies are. The Pi alone can't power it, or shouldn't be able to, or you really shouldn't. Now the TP4056. Be careful again to get the right one. This is the chip name, not the whole PCB design. I suggest the Type-C one. If you zoom in on it, the right side has 4 holes. The top and bottommost holes is where you plug whatever you're going to power in it, like the Pi. The innermost 2 holes are for the battery. The battery you'll charge and you'll also discharge from, not at the same time. There are some just for charging batteries. I got the idea to use this one because I originally planned to repair the power bank, not use the batteries from it. Now the orange Pi one listed here is too expensive in my opinion. I remember I bought 4 of them and each one wasn't this price. Anyway, this is just a reference. You can pretty much get any Pi you want. Forgot to add shipping to my calculation, so yeah, your local market may be cheaper. For further reference, the pin that has the arrow is a 3.3 volt line. The empty pin next to it is the 5 volt line, and below the 5 volt line is another 5 volt line. And I hope this picture is somewhat self-explanatory. If you wish to recreate it, you can just jump back to my working device preview at the start of the video. Well, that's it, I guess. The next step is designing an enclosure for this to fasten everything down and then move on to the next part, which is something about adding more servos, get this thing moving, solar panel maybe. Have any questions or corrections, leave a comment below. I'll sticky something if I made a mistake. Upcoming projects include some PC case reviews, 3D printing, CNC machining, custom water cooling, and other weird stuff. So yeah, thanks for watching and goodbye.